Okay, hi everyone. Really excited to be here today. My talk is going to teach you how you can build your own AI assistant. It's not too hard, but you'll learn about it right here. So as an intro, my name's Jonathan Dutson. I'm a security researcher at the Microsoft Security Response Center, MSRC. Specifically, I'm with the Cloud Vulnerability and Mitigations team. So we look at a lot of the bug bounty programs. If you're submitting a cloud vulnerability, my team's the one that looks at that, assesses it. Particularly on my team, I'm pushing for a content security policy, trying to stop XSS, pushing for automation, doing some root cause mapping things. And I'm really, really excited to be here today. So this is kind of what the talk will be like today. First, we'll have an intro to large language models, LLMs. Then we're going to talk about how you would integrate an LLM into an app or tool that you want to build. And then finally, I'll run through a few examples of things I've built so that you can have thoughts of what you might be able to build as well. So before we get to large language models, what are language models without the large? So language models, they analyze text data to predict word sequence probability. So the very earliest language models did statistics. You would analyze a bunch of text, run some statistics on it, and say, all right, given this word or this context, how likely is it that we're going to see this word next? So this is a really simple example here. This is a language model called an N-gram model, where if we're going to predict, we have the sentence, the hackers exploited how likely is it that vulnerability is going to be the next word? So what an N-gram model does, it says, well, how likely is it that does the first word? Given does the first word, how likely is it that hackers is the second word, and so on and so forth. And so using these statistics, you can calculate a probability for how likely it is that vulnerability is the last word in this sentence. So those were the early language models. Now, large language models are a little different. Modern language models use neural networks, which is a type of machine learning, to generate word sequence probability. So we're not going to do a deep dive into how large language models work or neural networks work. All you really need to know is it takes some input variables, passes it through a network of equations, and then generates some output variables. So for large language models, the input is text, and the output is also text. This is from Wikipedia. A picture of a neural network. When we call them large neural networks, just how big is that? So with this Wikipedia sample neural network, it's about 26. One way we can calculate how large a model is by counting up what we call the weights and biases, these numbers. Basically, if you look at that image, count up all the arrows and most of the circles, that's going to be what we call our parameter count. So this Wikipedia image has about 26 parameters. GPT-2 has 1.5 billion, and you can see it grow and grow with Meta. Llama 2 is an open source model from Meta with 70 billion. GPT-3, 175 billion. These are massive, massive models. There's a question mark by GPT-4 because they haven't actually published exactly how many parameters are in GPT-4. Some people have guessed it's over 1 trillion. Who knows? But they're growing, and you can see they grow a little bit exponentially. So when we think about how language models have evolved, this is one frame which can help us. This is from a coworker of mine, Andrew Pavard, that can help us think about how language models have evolved over time. So the example of the early language model N-gram, that is an example of a purpose-specific model that was really good for one particular thing, but your data source had to be related to the thing that you're trying to get the language model to be good at. Starting with models like BERT and GPT-2, these are large language models, and they're really good in a wide variety of settings. But for them to perform their best, they really needed a lot of fine-tuning for your specific use case. But starting with GPT-3, we can think about these as instruction-tuned models. So GPT-3 performs very well in a wide variety of settings without having to have any custom model. You can use the base model, and instead of training on custom data, you just give it different instructions that tell the model what you want it to do. Now, LLMs aren't great for everything. They have a lot of strengths, they have a lot of weaknesses. What they do really well is things like summarization, text completion, code assistance, and they also can be really fun to play with in seeing how creative they can be. But some of their major limitations, one of the biggest is something we call hallucinations, which is if an LLM doesn't know the answer to something, sometimes it just makes things up. We call it a hallucination. And the reason why LLMs have these hallucinations is because there's no understanding of reality in a large language model. All they do is predict text. Given this text, let's guess what the next word or sentence is going to be. So it doesn't know anything about facts beyond, hey, if I say something untrue, that doesn't seem like those words make sense given all the data it's ingested. Another weakness is that there's no real-time learning or updating. So for a long time, ChatGPT, for example, had a knowledge date of September 2021. If you asked it anything that happened after that, it wouldn't know. Recently, they've actually updated that, so it also ingests data. It can do internet searches to kind of make up for that gap past 2021. But by default, these models, they can't update in real time. So to demonstrate the creativity bit as a strength, I asked ChatGPT to give me a quote from a famous villain about why cybersecurity was so important on the Death Star. And I really like, he says that the true strength of the Death Star is not only its destructive capabilities, but its impregnable shield of cybersecurity. So I think they probably spent a little too much time on cybersecurity because their physical security was not impregnable, as we all know. But this is kind of a fun example of the fun things LLMs can do. I really love OWASP. They have a top 10 list of vulnerabilities for web applications, which is something I look at a lot. They also recently came out with a top 10 list of security weaknesses for large language model applications. So a few of those include prompt injection, which is when you could inject something into an application that the developers didn't intend for you to be able to do. So imagine if you could make ChatGPT respond in a pirate's voice or something. That would be kind of like a prompt injection bug or attack that you could perform. Insecure output handling. If you're taking the results from an LLM and using it in an unsafe way, that can lead to problems. So say you're outputting results of an LLM onto a web page, and somebody asks your LLM, hey, what are some cross-site scripting payloads I could use for a project? If your web page is using those in HTML, not encoding them, that could lead to a cross-site scripting bug on your website. So you have to be sure you're encoding the output correctly. The next two examples of these 10 are kind of related. Because, remember, these LLMs have no understanding of reality, they can't be 100% accurate all the time, and so we shouldn't give them excessive agency, we shouldn't give them permissions to do things that are incredibly sensitive, and we also shouldn't be over-reliant on them. I'll also note, if you're interested in finding weaknesses in AI, Microsoft just released an AI bug bounty program, so you can look up the details about that online. And if you find a bug, report it. My team will take a look at it, and you can get rewarded for that. So now we know a little bit about what language models are, large language models. Now let's talk about how we would build an LLM app. So to start, this is an app I built. I'm automating my job away. Hopefully not really. But how I like to think about it is we can use LLMs to do some of the more menial or trivial parts of our job. And so then now I'll have more time to do the things that I'm more interested about or that require more of the human touch. So I'll go into more detail about exactly what this is doing and how it works later on. But a big part of my job is looking at these vulnerability reports that my team receives and deciding how bad the vulnerability is. We do get quite a lot of false positive reports, and so I used an LLM app integrated into this bot to help me decide whether reports are false positives or like non-issues. And so we'll get into more detail about that a little later on. But the first step, you've got to choose an LLM. There are lots of choices. The GPT models are really great. Llama 2 is really cool because it's open source. In this talk, I'm going to use examples using the Azure OpenAI API because that's what I have access to at work. But the principles are going to be the same, no matter what LLM you choose. So when you're building an app, You probably have all heard about prompt engineering. What does that mean? So the inputs in these instruction-tuned models include a system prompt, a user prompt, maybe additional context, and then we have some generated text that we're trying to create. So the system prompt is, for example, if you ask GPT to help you hack your neighbor's Wi-Fi, it's probably going to tell you, no, I can't help with that. Why is that? That's because the system prompt, the creators of OpenAI have given it rules and guidelines that tell it how it should and shouldn't behave. And then the user prompt is me when I'm using ChatGPT, for example, right? But if you're building your own app, now you're the one who's creating this system prompt, telling the LLM the rules and guidelines it should follow, any boundaries. This is not perfect, and these can be bypassed, so it shouldn't be treated as a security boundary. But system prompt can help define your app's capabilities. It can provide examples so that it responds in a certain way. So developing a system prompt for your app is a really important step of this process. So here's an example of an example system prompt, and then a user prompt, and then how a bot might respond. So if we tell this LLM, you're an AI assistant, you help people find info, you respond in rhyme, then no matter what the user says, it's going to respond in this kind of format. So again, we can't control what the user is going to say, right, if other people are using our bot. But we can control this system prompt. This is one thing I really liked this is from some Microsoft AI documentation online. But LLMs, if you're trying to define a good system prompt or even a good user prompt, it's kind of like asking, hey, what's the first thing that comes to your mind when I say blank? Right? So this creating this system prompt, that becomes input to the model, really determines how the prompt will, how the output of the bot will respond. So these are a few best practices about prompt engineering. So one, be specific. Leave as little to interpretation as possible. This will help the bot respond in a way that you want more often. Be descriptive. Sometimes analogies can help. Double down. Sometimes it helps if there's something that's really important that you want your LLM app or tool to do. If you say it a couple times, it's going to have extra weight in that LLM model. Another interesting thing is that order matters when you're developing an LLM tool or app. So there's something called recency bias, where sometimes if you have instructions before and then or instructions after, it's going to favor the most recent instructions a little bit more than the first. So you might want to play around with where exactly do I put this instruction, before some content, after some content. That makes a difference. And then finally, give the model an out. So you'll see this sample did it. What is an out? The last sentence of the system prompt here, if the user asks you a question you don't know, say so. This helps reduce hallucinations, because if the bot knows that it's okay if it doesn't know the answer, it's going to be less likely to just make something up. Again, this is not foolproof. We can't rely on it 100%, but it helps it become more accurate if you give the system an out. So how would we do this? Again, this is an Azure OpenAI example where I've built apps. It would be applicable other places. Say we want to build an app, for example, that helps recommend mitigations for different vulnerabilities. So this is the Azure OpenAI playground where you can test out system prompts and then also provide examples of what you think the user might ask your bot, and then examples of how you want the bot to respond. So these models, they use something called few-shot learning, which is where it gives a lot of weight to the examples that you provide. And so even if I just include this one example here of how I want the bot to respond, it's going to do that the next 100 times a user asks a similar question. So that's a pretty cool way to help refine the bot's output to look just how you want it to. What does this look like in the back end, right? So we've developed the system prompt, we've given it an example. Now in the back end, what happens? So this highlighted blue is the input that I'm sending to this API, which includes the system prompt. It includes the example that I developed. And now it includes the first question from the user, this user prompt. That all gets sent to the LLM API. And then I get a response, which is green, which is this output. And I'll note, so you can make a lot of different kinds of apps. If you're doing a kind of chatbot style app, the next time the user asks a question, so after they ask about dependency confusion, if they ask another one, this whole thing, input plus output, becomes the new input. And that's how ChatGPT, for example, knows the context of what you said earlier on in the conversation, is because the whole conversation is actually sent as context to the bot each time. But you'll notice as well here, so a user is asking, how can I prevent dependency confusion? It's responding in the exact same way that we specified in this example, right? It's a list of 3 ideas. So that's just demonstration that this few-shot learning can be really powerful. Also, in Azure OpenAI, there's lots of ways you can integrate this API into your tools, so you can copy directly as Python code, or you can take a JSON file and then integrate it in whatever way you want to your app. So there's a little bit of background how you can create an LLM app. Now I'm going to walk through some use cases, 3 examples. CWE classification, that false positive detection I was talking about, and then how you can integrate custom data into your app. And the reason I chose these 3 examples is because they all involve text summarization, text completion, those kinds of things that LLM are a good fit for. So LLMs are not a magic bullet, but there are certain situations where they can be really helpful. So to start, just some context, a big part of my job is this MSRC case assessment. When we receive a vulnerability report, I look at it and decide how severe is this, what's the impact of this, what is the root cause of this. And one helpful way to describe the root cause is using common weakness enumeration, MITRE's CWE, which is a common language I can use to say, hey, this is a SQL injection bug, cross-site scripting bug, and other people know what I'm talking about. So this text is the LLM system prompt that I provided for the tool, saying, I'm going to give you a description of a vulnerability or a weakness. Please respond with the CWE that best matches it, and also link to the documentation of the CWE. This is a really simple example. Integrating it into the bot, it looks something like this. I say, hey, I want to get some CWE info. What kind of bug are you looking at? Dependency confusion, and it provides me with this answer. Now, you think that's pretty simple, and I could have just Googled that. That is absolutely true. But the cool thing about this is it's very forgiving in what kind of inputs you put into it. So I can also, this is text from a HackerOne report that now I'm pasting in this bot. So I'm describing this vulnerability. The LLM says, hey, this looks like an access control issue, and here's the reference to the documentation. And so you notice the nice thing about this is in both situations, the output from the bot is exactly in the same format. So I kind of sometimes think about it as I can create an API that it doesn't matter what input I'm giving into it, it'll get me a response in the same format. So if I have a tool that requires, if it requires CWE information in this exact format, this is a really nice way to do it. So this is a little bit more of a complex example. I mentioned this earlier. There are those false positive or non-issue reports we receive. And I don't like looking at them because it takes away my time from looking at the really interesting bugs that we get. So one of these kind of non-issue reports we receive is just a misunderstanding. Sometimes people send us links to these keys and they're like, hey, these keys are private, you've disclosed them online, they're a really big deal. Actually, that's not true. They're just public keys, they're OpenID Connect endpoints, they're supposed to be public, and so there's really no issue with the thing that the user is reporting. So I have a list of about 15 of these non-issue cases that I compiled into a really big LLM prompt. And then I ask the LLM, tell it, I'm going to give you report data. Please let me know if it looks like something that's in this list, and respond in this format. So I say, here I say, hey, if this looks like a non-issue, say it's potentially a non-issue. And that was deliberate because, again, we can't rely on this 100%. But if it says, hey, this is potentially a non-issue, and then it also references a case number that I can go look up previous cases and see, oh yeah, other people have looked at this, here's the explanation why, that helps me get through these a lot faster, and I'm not wasting time on cases that I don't need to be. And we also give the model an out here, like we talked about with the best practices, right? If it doesn't match anything, if the vulnerability report is legitimate, say so, so you don't have to make up a reason why it matches something in the list. So again, this is what this looks like. I asked the bot, hey, can you help me find if something is a non-issue? And it says, provide the case details. I can paste it in there in whatever format again. And then it'll say, in this case, hey, this looks like it's by design. It references a case that I can go investigate, and it references some documentation as well. So does this work? It actually works pretty well. So I did an initial test. I took 126 reports that we had received at Microsoft, about 100 of which were legitimate vulnerabilities, and then 28 were examples of these kind of non-issues. And so it identified 77% of the non-issues correctly, and then had only an 11% false positive rate. So again, this is not meant to replace me. It's not really meant to automate my job away, but it's to help me do it faster so I can get onto other cooler things. So the third example, something kind of cool you can do is you can also integrate custom data into your LLM. So there are a wide variety of use cases for that. So for this example, I thought, what if I was developing an app to help engineers on my team fix security vulnerabilities? And I could provide data custom to my org. So for example, I uploaded a document here that said, hey, if you're onboarding to the team, what are some useful security resources you might want to use? And it references those security resources. Another thing you might do, if I say, I uploaded a document that said, hey, in my environment, these are IP ranges that are sensitive and I don't want people to access. So now if somebody asks the LLM, hey, I have an SSRF, are there any IP ranges that I should mitigate or pay special attention to? Then the bot is going to say, oh, yes, there are. Here they are. And it also references, you see at the very bottom there, if it's not too small, it'll reference the custom data. This is just a text file that you uploaded, so people can also cross-check themselves. One thing that's cool about this custom data is that you can also make the bot respond only based on information provided in your custom data. So there are probably a lot of blogs out there that say, hey, when you mitigate SSRF, here are the IP ranges you use, and probably those are pretty accurate. But if you want it to only do the data that you provide it, that's a setting that you can make. And this data also, it's not shared with Microsoft or OpenAI, so it's your data. It's not trained for the future version of ChatGPT or something on there. And I'll note, these three examples, they're pretty simple, but there are actually a lot of really additional powerful tools and resources you can use. So one that I really like is Semantic Kernel, which is, it's open source. It's an AI orchestration SDK, which lets you connect LLMs with other tools or applications. So one use case for this would be, right, LLMs are really good at text, talking to people, chatting to people. One thing they're not good at is math, because they don't have any understanding of this previous logic. So it's not going to know how to do a math problem. But you can use something like Semantic Kernel or other orchestration SDKs to take an LLM chatting with a user, extract parameters for a math equation, say, and then pass that to, if you have a tool that's really good at math, Wolfram Alpha or something, you could pass it to that tool, get the response, pass that back to the LLM, and give that back to the user. So it's a way basically to integrate LLMs with lots of other tools that you can use. Another thing you can do is you can create custom models. So even though these instruction-tuned models don't require custom training to be really good, you can still customize them to your specific data and use cases as you want, if you want. And one benefit that this provides is if you train it on a lot of examples of user input and expected user output, then you no longer really have to provide examples with the user prompt, right? And then the bot will still respond in the way that you expect it to. Training can be expensive. It takes a lot of resources to train the custom model, but this can be a good option in a lot of use cases. And then finally, this is not my GitHub repo. Awesome LLM, it's a really cool resource though. It's packed with papers, tools, tutorials. You can learn a lot about LLMs at this resource. I highly recommend it. And that's the talk. Thank you so much for coming, and I'm happy to take a few questions. Yes. Yes, great question. Yeah, so Microsoft and OpenAI have an API you can use to create LLM apps. They're both paid. Meta has Llama 2, which is another very powerful LLM that's free and open source. So a lot of researchers use Llama because it's free. But yes, for the GPT models, I believe those are all paid APIs. Except for GPT-2, which is free, but it's not that powerful, so you probably want to use something a little later. I am not sure how much it costs, unfortunately. But hopefully, I think the website's probably have info on that. Did I see another question here?
Yeah, so say that you use semantic kernel. Have you ever tried using LangChain, Haystack?
No, but I've heard about LangChain. I think it does a really similar thing and is also really powerful, like really effective tool. A great way to like increase the impact of LLMs. Yeah.
When you were doing your assessment for this project, did you look at expanding it to the entire user base of the company, or was it just focused on like an IT security team?
Yeah, that was just limited to security team, and in fact, it's just my security team. And in addition to that, just a specific kind of MSRC case, because we get Windows bugs, we get online bugs, Xbox bugs. So it was actually very limited, but I do hope it's in the plans to kind of expand that to future to other bug bounty programs, so that like it can help speed assessment in more situations. Wow, that was fun. I'm about out of time, so if you have any other questions, please come see me. I also have mini badges to give out if you want one, and thanks again for coming.